I love tabletop roleplay games, and we often use dice to add a random chance to our games. But are digital dice or physical dice better? I saw this hot take on Dimension 20's Adventuring Academy where Brennan Mulligan argues for physical dice, and Aabria Iyengar is on the side of digital dice.
I can't see what the algorithm is. Show me the math.
Have you salt tested all of your dice, Brennan? The only thing that is fair is math.
You can find this video on YouTube and dropout.tv. There is a lot to consider here. On the one hand, how do computers generate random numbers? On the other hand, how do you know physical dice are fair? And are digital dice more fair than physical dice? Today, I want to chat about random numbers. In this episode, I'm going to focus specifically on physical dice and how they work and what makes them fair or unfair. In a future episode, we will dive into digital dice and demystify how they work. Hi, my name is Argentarius, and welcome to Menagerie Chats. We often use dice to give us a random result, a result that relies on chance. That is, we cannot predict the result ahead of time. Let's take a look at a 6-sided die. Because it has 6 sides, we expect it to have a 1 in 6 chance to land on any side. Similarly, a 12-sided die, we expect to have a 1 in 12 chance, and a 20-sided die, we expect to have a 1 in 20 chance. But why do we need dice? Couldn't we just come up with random results ourselves? I asked a number of my friends to give me the results of 20 imaginary coin flips, no actual coins involved, just using their minds. And for each result that they gave me, I did a real coin flip. But I'm using an Irish euro, and an Irish euro doesn't have a head, but instead we have a harp. So I have harps and tails, but the abbreviation is the same. So I put these both, the human-generated coin flips and my real coin flips, into 2 tables. On the left, you can see long strings of repetitions, and on the right is more evenly distributed, a bit more broken up. Can you tell which table is created by humans and which is the real coin flip? Feel free to pause this video while you take a moment to decide. Tick tock, tick tock, tick tock. If you guess that the real coin flips is on the table on the left, where you see longer repetitions, then you are correct. Let's take a closer look at the real coin flips. You may be surprised to see so many repetitions, and it at least feels that there are more patterns. For each row of 20 flips, I've counted how often a head or tails occurs in the row. We would normally expect to see a balance of about 10 on each side, right? Out of 20 coin flips. The real coin flips only had 10 heads and 10 tails for about 4 out of a total 13 rows. It's not until we look at the whole 260 coin tosses that they start to become more balanced between heads and tails. Now, let's take a look at the imaginary coin flips my friends provided. 7 out of the 13 rows have exactly 10 heads and 10 tails, which is more than half of these rows. I also counted the number of streaks that we find in these tables, and the highest streak each of my friends were willing to go was a 5 in a row, and only 2 friends did this. Though if we count all the results as a continuous stream, there is 1 6 in a row. We can compare this to the real coin flip results, which shows 2 7 in a rows and 3 6 in a rows and 4 5 in a rows. So there's a lot more streaks there. When I took a statistics class, the teacher had us do this exercise. First, we had to try and create random coin results, and then we had to flip a coin. So I knew what to expect, but I'm actually quite surprised that my friends came up with results closer to random than my statistics class. I wonder if that says anything about me if my friends are closer to true random. Editor Argent here. So after I filmed this and started editing, I actually got a late submission from a friend, and this is all H's and 1 T, and this is the most unhinged result. Thank you. Well, these results do at least show that people generally are not very good at coming up with true random results. We start becoming uncomfortable when a result repeats itself too often. After all, we expect there to be a 50-50 chance for each result, so we feel that they should be reflected in our choices. We tend to be biased toward an expected result. Actual random results do not care what came before. Each coin toss has the same chance that it did previously. Previous tosses do not affect the next coin toss, and small samples are very unbalanced between possible outcomes, and we see more streaks and longer streaks than we do when we try to generate the randomness ourselves. Now I know what you're thinking. What does this look like when we use dice instead of coins? Well, I rolled a 6-sided die 225 times just to show you. You can have a look at this diagram. I put the results of each roll on a 15 by 15 grid. On the right side, I have counted how many times each possible outcome appears for the row of 15 rolls. As you can see, the values do vary wildly. I've highlighted the particularly high and low occurrences. If they were balanced, we would expect each side to appear 2 or 3 times for each row of 15 rolls. When we count all 225 rolls, we see that each value starts becoming more evenly balanced. For 225 rolls, we would expect each side to show roughly about 37 to 38 times if they were perfectly balanced. Rolling a 4 in a row has a 1 in 216 chance, so there's no surprise I had one in my results. However, rolling a 3 in a row has a 1 in 36 chance, which means we would expect only about 6 or so of these in 225 rolls, but I got 10 of them. This is one of the ways that dice and randomness is not intuitive to us. Just because something is unlikely doesn't mean it won't happen. In fact, we can expect small sample sizes to vary wildly, which is why good science uses large sample sizes and repeatable experiments. This reminds me of a time I was playing Yahtzee at a queer game night, and on my final turn, I rolled a Yahtzee in one roll, which won me the game. That's 5 6-sided dice landing on the same side in a single roll. That's a 1 in 1,296 chance, which is less than 0.08%. Wow. In physics class, we learn how to calculate the result of throwing objects with some force. So if we know all the starting positions and the forces involved, then we should know the result of the dice, right? Well, that may be true, but as soon as the dice begin to tumble, the system becomes chaotic and hard to predict which side the dice will land on. It is possible to predict the trajectory of the dice from their center of mass easily with physics, but the tumbling makes it near impossible to predict which side it will land on unless you have perfect knowledge of all conditions. If you are off by even just a small amount in measuring the forces and angles, your prediction will be completely inaccurate, especially if you have multiple dice knocking into each other. If we, say, drop our dice to prevent them from tumbling rather than rolling them, then we can potentially more accurately predict the results. However, many people would consider this cheating since you are not actually rolling the dice. The weather is another chaotic system that is notoriously hard to predict, especially in Ireland. If you had perfect knowledge of everything involved, all the particles, all of wind, all the water, the sun, the moon, everything, then this might be possible to predict, but even the tiniest change can have drastic results. By the way, chaos theory is where we get the term butterfly effect. Edward Lorenz used a hypothetical gentle beating of butterfly wings influencing events over time, which leads to tornadoes or hurricanes occurring in some distant part of the world, to illustrate just how big an impact a tiny change that we may think is irrelevant can have on a chaotic system such as the weather. Once you can recognize it, you will find chaotic systems everywhere. But for now, just know that we get randomness from chaos. How do you feel about knowing that you can hold the power of chaos in your hands by simply using dice? Or should we call them chaos dice? This is for all you chaos gremlin out there.
Yes. You become a little chaos gremlin. You're always a chaos gremlin.
I'm always a chaos gremlin. That's how I identify.
There you go.
What are you, chaos gremlin?
There you go.
Before we get into fair dice, let's first look at how we might cheat by making unfair dice, at least in our imaginations. So unfair dice should be biased towards a desired result. meaning it's more likely to land on one or more faces than the others for any given roll. I can think of a couple ways to make unfair dice. First, we could change the shape of the dice to make it more likely to land on one face rather than the others. However, this does change the appearance, and all but the slightest of changes will make it relatively easy to spot if you are using unfair dice. Second, we could change the weight distribution of the dice by making one side heavier, often called loaded dice. We could also potentially combine the two methods to make subtle but unfair dice. However, this can also happen with manufacturing defects too. A dice maker can make the dice unintentionally unfair. There might be air bubbles when the dice is molded, or the shape of the mold itself might be imperfect, or both. Okay, let's talk about fair dice now. Ideally, fair dice should be completely unbiased. Every side should have the same chance to land for each roll. But how do we know if our dice are fair? Aabria asked Brennan if he salt tests his dice.
Have you salt tested all of your dice, Brennan? Are they fair? Do you know?
So I looked up how the salt test works and got what I needed to perform my own salt test. The idea here is to put your dice in salted water. You need enough salt so that your dice will float. Then you roll it in the water. The way that a salt test works is to amplify the effects of any imbalances or imperfections in the die. It is simple enough to do at home without needing special equipment, but it does take some time to do. And if you're a little clumsy, it can be a little messy. Next, Aabria also mentioned that the only fair dice are the ones casinos use.
The only fair dice are the ones that casinos use.
She also mentions that anything you add to decorate your dice, for example, will make your dice unfair.
Everyone else, every time you put a little baby tooth or some glitter, fucks up the dice. So your dice aren't fair.
So I did a bit of research, and many casinos do go through great lengths to ensure that their dice are fair. My research led me to finding a checklist published by the Worldwide Casino Consulting. This checklist has a number of tests, to say the least. Many of the checks are quick inspections for authenticity. Casinos tend to use dice from a certain manufacturer, and they're standardized. That way they know that no one has substituted their own dice, at least very easily. So for example, they'll check the logo, they'll make sure opposite sides add up to 7, and check that the 3s are slanted the expected way. There are also visual checks for fairness, such as checking the edges for deformations, making sure the dice sides aren't shaved down, and looking for bevels. It's hard to check for asymmetric bevels, so they just don't allow them in casinos. And there are the checks that require tools, such as measuring the dimensions and the weight, using a magnet to check for metal, and spinning the dice to check for imbalances, much like our salt test. Casinos don't want to be suspected of cheating, nor do they want players cheating. Most will perform regular inspections of their dice, and casinos will go through great lengths to get the dice that are as fair as possible. But the act of using them does also warp them, and so through regular use, these dice have to be continually refreshed to ensure that players are using fair or as fair dice as possible. So, are physical dice fair, or can they be fair? Well, if we want to get very particular, and by that I mean down to the molecular level, we will find it's impossible to make dice that are perfectly fair and unbiased. The perfect dice with perfect geometry and even weight distribution can only exist in our minds. If you want to check your dice to see how biased they are, one of the easy ways to do it is with a salt test. That can be a solution to see if there are any major biases and if your dice are, work well enough for you. We're still left with the question though, can digital dice be more fair than physical dice? Well, we'll look into that question in another episode. Thanks for staying to the end. I hope you enjoyed this episode. My goal is to be able to work on this full time. I've worked in software for a variety of industries for over 2 decades now, and I started making videos in 2024. I want to share my art and creativity with you, and my hope is that I can make the world a slightly better place along the way. You can help me along this journey by checking out my videos and podcasts. You can search for Menagerie Chats for talks and video essays like this one, and Argentarius Reads if you want to hear me read. You'll find both on YouTube and most podcast apps. Interacting and sharing my videos helps me, and I always appreciate reading what you have to say in the comments. To support me more directly, you can become a member on Patreon and access perks like extended episodes and exclusive content. Just search for Argentarius or find the link in the description. Speaking of Patreon, for this episode, I want to give a shout out to Salem R. I bless your dice to roll in your favor. I also want to give a special thank you to all my friends who helped me with providing imaginary coin flips. You are a random bunch. And I hope to see you in the next episode when we'll dive into digital dice.